So this is the alternate method of how we could solve this problem. We have our equations. Iron 3 oxide plus carbon monoxide yields iron and carbon dioxide. We have the phases labeled solid, gas, and we are given an amount of 158.0 grams of the iron 3 oxide, which from that I could divide by the molar mass, 159.7, and get the amount in moles, 0.9894 moles. The ratios, which goes here, is 1 to 3 to 2 to 3. So the question is asking, calculate the total mass of the gases that are present. So we're really only worried about the amount of carbon monoxide and the amount of carbon dioxide. Now, we are told that we start with 90.62 grams of carbon monoxide. But remember, this is the excess. So we'll calculate how much of this gets consumed and then subtract it from the given amount, and then that way we'll know how much is left over after the reaction. Okay, so 0.9894 moles, and that's per every 1 mole in this reaction. And so if I want to know the amount of carbon monoxide, I would take this value times 3, which gets me 2.9682 moles. Turns out that is the same amount for carbon dioxide, since it also is in a 1 to 3 ratio, so 2.9682 moles. We don't need to worry about the amount of iron because we are only worried about the amount of gases that we get in the reaction. Now that we know how many moles are consumed and produced, we can multiply this number of moles times the molar mass for carbon dioxide, and that gets us 83.14 grams of carbon monoxide consumed, and 2.9682 times the molar mass of carbon dioxide is 130.63 grams that are produced. So that's how much total is produced. However, this is how much carbon monoxide we consume of the 90.62 grams. So if I take 90.62 minus 83.14, then I get leftovers of 7.48 grams of carbon monoxide that are not reacted or consumed. So to get my final answer, I need to combine these two with each other, and so 130.63 grams of carbon dioxide plus 7.48 grams of carbon monoxide gives me a total of 138.1 grams of gases left after this reaction, which is letter A.